Okay guys, we're going to try something a little different today. I'm going to record this lesson and upload it to Schoology, and you guys are going to listen to it with your earbuds, either on your tablets, which hopefully you have by now, or if not, your phones. If there's something you don't understand, just pause the video, go back, re-listen to it, and do that until you understand. If you've done it several times and you still don't understand, then let me know. So a lot of this is stuff that we've already done. We're going back to the conservation of momentum. All right, there's a couple of things that I want to add to this. So I'm going to give you a definition. Okay, I'm going to give you 2 words to write down the word. Okay, if you hear my dogs, they're playing in the background. Okay, the first word is elastic collision. Okay, an elastic collision is a collision where 2 objects bounce off of each other. So objects bounce off of each other. Okay, an example of this would be some billiard balls, okay, that just bounce off of each other. The other word, let's see if this works. The other word is inelastic collision. Okay, and that's where the objects stick together during or after a collision. Objects stick together as one object. Okay, so we've discussed several examples of inelastic collision. One example that we've already talked about is when Grandma picked up her grandchild at the skating rink. Can't remember the name of the grandchild, but another example is if you take a ball of clay, okay, and you throw it at a window and it sticks on the window. That's an inelastic collision because the clay did not bounce off. If you have 2 cars or two cars that are moving head-on and they collide, sometimes instead of hitting each other and bouncing backwards, they stick to one another. All right, so inelastic means they stick together. Elastic means they bounce off. And the way I remember that is elastic is like a rubber band. Okay, it's elastic. It stretches, and a rubber band. Just take the word rubber and rubber ball. A rubber ball bounces. Okay, so that will help you remember that elastic collisions bounce off of one another. All right, now that you've got those 2 new definitions, let me show you some of these formulas that we do not need. Okay, we do not need let's see. P equals m times v, we've discussed. P is momentum, m is mass, and v is velocity. Okay, this one you do not need. This one you do not need. Okay, the rest of them we've pretty much already discussed. Momentum before a collision, P is momentum, so the momentum before a collision equals the momentum after a collision. Right? That's the conservation of momentum. And then this is just another way of stating that. The net momentum, so in other words, that's kind of like the total momentum before a collision equals the total momentum after. Just 2 different ways of writing that. Here is the formula that you guys are going to be using, and I know it looks a little crazy, but it's really not that bad. This is saying that if you have 2 objects, the mass of the first object, so m1, times the velocity of the first object, plus the mass of the second object times the velocity of the second object before the collision, has to equal the mass of the object, first object, times the velocity of the first object, plus the mass of the second object, times the velocity of the second object after the collision. All right, and I'm going to do, I think, 2 of these with you. All right, let's look at this first problem. When these 2 freight cars of different mass collide and couple, so that means that they're sticking together, they're coupling, what will be their resultant velocity? All right, so all we have to do is look at our formula here and find these different variables. Now you will be given every variable except one, okay, and that's the one that you're going to have to solve for. All right, what they're asking us for here is what is the velocity after the collision, okay? So let's take a look at what we've got here. Okay, we're looking for M1 first. M1 is going to be 10 tons. So M1 before the collision is 10. Okay. Velocity 1 before the collision is 4 meters per second, so 4. Okay. M2 before the collision is 30 tons. And V2 before the collision is 0 meters per second, so it's at rest. Okay, so this one's going to crash into this one that's at rest. That's all before. Now let's come down and look at what we have after. Mass 1 after is going to be these 2 added up together. Okay, they're now 1. They coupled, they're stuck. So that's going to be 40. Okay, all I did was add 10 to 30. 10 plus 30 equals 40. These are all after the collision now. V1 after the collision is, I believe, what they're asking for. Okay, that's the question. Okay, so all we really need in this situation is this one. Okay, because it's just one object now. All right, so let's set that up. M1 was 10 times velocity 1 was 4. Oops, that should be a times. Okay, we're going to put that in parentheses. Plus mass 2, which is 30, times 0 equals 40 times V1. This would be after. Sometimes they use a prime up in the upper right hand corner. Okay, so we're going to go back and do what's in the parentheses first. 10 times 4 is 40, plus 30 times 0 is 0, equals 40 times our unknown. There's my little prime. Okay, so 40 see if I can get rid of this. No. 40 equals 40 times my unknown. So in order to isolate my unknown, I have to divide both sides by 40, and I get 1. The velocity after the collision is 1 meter per second. And that makes sense. Always look at it to make sure it makes sense. Okay, it was going 4 meters per second when it was only 10 tons. Then it went up in mass, so the speed should go down. Okay, that's 1.